Kubernetes is great. Grab a Helm chart, run a simple command, and boom! You've got infrastructure that scales automatically and handles things like high availability out of the box. But Kubernetes is also clunky and slow. We're talking seconds to minutes. So the question is, can we turn that streetcar into an F1 racer? At Unikraft, we wanted to integrate it with Kubernetes transparently, without giving up what makes our platform special. Starting workloads in milliseconds, scaling to zero, resuming them just as fast, and doing all of that at massive scale. The result is a transparent integration where our platform appears as a standard node, one you can add to any cluster, whether that's through Amazon, Google, or Azure, or your own setup. Pods get scheduled to it just like any other node. The difference is that those pods run as strongly isolated microVMs, not containers, and the Kubernetes counterplane never knows the difference. Here's where it gets interesting. Those pods always show up to Kubernetes as running, but behind the scenes our platform scales them to zero when idle, and wakes them back up statefully in milliseconds the moment the next request arrives. The power of Kubernetes, the speed and scale of Unikraft, a match made in heaven. Oh, and one more thing. A single node can run up to 100,000 pods. And we're gonna check that out by using this Google cluster that I have here, but this would work with any of the usual clusters that you're familiar with, like Amazon or Azure or whatever that support Kubernetes. Here I am listing all the nodes we have available, and we have these 5 Kraftlets and the demo one, which we're gonna use today. And let me showcase the scale we're dealing with. I'm going to list all the pods we have at the moment, and these will actually take a bit because I have a lot of them. And there it is. We have 10k pods, and all are managed by the 6 previously shown Kraftlets. All these pods are scheduled to any of those Kraftlets, and importantly, they appear as running, as you can see in the 4th column. We'll check that out later. So let's actually deploy something. This is the configuration that we're gonna use. We can specify a lot of things, as you are probably familiar with. But more importantly, we can also use annotations to set specific values for Unikraft Cloud. We're enabling scale to zero. We're doing so statefully and within half a second, where application would go into standby mode, consuming no resources. So let me watch the pods as they come and then apply deployment. I want to watch it here, and then I can apply the YAML file. And as soon as I hit it, we can see our application is immediately up and running. Very good. So let me actually inspect this particular pod. We're going to get its YAML, which will give us its UUID, which is here. And then we're going to inspect this UID in Unikraft Cloud to see that it's actually not running at all. So we can instance get the UID and watch it. We can see it's in standby mode, consuming no resources. And to check that out, we're going to curl the public FQDN, as we can see here. And as soon as I hit it, the pod is going to come back up and into running state, but it's just for a second, for half a second, in fact. Let me do that a couple more times so you can see. There you go. And one last thing that I wanted to show you is that this was built for scale. So I'm going to watch the pods again as they come, but instead I'm going to now replicate this 10 times, create 10 replicas. As you can see, that replicas come immediately with no delays. As for the actual compute, Unikraft can leverage any of the hyperscaler products, be it AWS EC2 regular or Metal instances, or the GCP and Azure equivalents. Or you can rent or use your own Metal or VM and point to your Unikraft enhanced cluster at it. Welcome to the era of millisecond large-scale Kubernetes. Get in touch with us to directly experience what the next leap in Kubernetes scale, speed and security looks like.